So welcome everyone. I'm super happy with the turnout because you never know with these things how many people are going to be interested in the space, but this is awesome. So genuinely thanks a lot. Quick show of hands, who is familiar with containers and so forth? Awesome. Who is using containers in production? Oh, that's about, I reckon 30%. Yeah, brilliant, that's great. So hopefully you guys will learn something, but this is kind of it's more skewed towards the intermediate stuff, if that makes sense, yeah? But we'll go through as much as we can, introductory, intermediate, and a bit of advanced, hopefully as well. So containers, it all sounds so good, doesn't it? As in we kind of carve up our application, we put it into containers, all nice and shiny, everyone loves the latest tech and so forth. This is a good thing, yeah, a good thing. The only snag is if what you're putting inside the container, if you're taking your application, jamming it in a container, if it's a bit of a tire fire, what you actually get is tire fire in a container, yeah? This is not a good look. But as I'm a consultant, this is how I make my money. This is DevOps, yeah? Putting out the fire, basically. It's a real genuine challenge. New technology comes up. Any of us who've been in the industry for more than a few years realizes there is no silver bullet, yeah? But I think there's a lot of advantages. I think there's a lot of advantages with container tech. And so let's kind of walk through that and continuous delivery today. So for my sins, I've actually written a free O'Reilly book, which I'll put here. You can grab at the end, all right? So free mini O'Reilly book there. And I'm writing a full book as well. And I've started realizing that, writing a book is genuinely hard. Yeah, no doubt about that. But continuous delivery itself is a large topic. Yeah, it's kind of perhaps a subset of the DevOps stuff or whatever, but it's still a large topic. Now, I'm a consultant. I do a whole bunch of different stuff. I do hands-on coding, I do like leadership stuff, and I do architecture. I've been very lucky to have many different roles over the years. We're not going to focus on the business stuff today. This is pure kind of tech, continuous delivery stuff, yeah? We're not going to be looking at things like value stream, for example. I think PaaS, things like Cloud Foundry and serverless are super, super interesting. I'm doing lots of work now with clients. I'm looking at AWS Lambda, serverless stuff. But this presentation pretty much assumes you're all in on containers, deploying into a container. I'll probably do a new talk on serverless in the future. I'm not a big fan of live coding. I'm no good at it, to be honest. So I'm going to focus more on the processing tooling. The book, if you can't get a hard copy today, you can pop along to the URL there and get a free copy if you give your email address. And the book goes into a lot more specific details. It's got Docker files, it's got scripts, all this good stuff as well, all right? So this is going to be more high-level stuff, and you can come and grab me in the breaks today or tomorrow, around half of tomorrow as well, and come and chat through some details if you want there as well. But that's the kind of setting expectations there. I always like to do sort of TLDRs, takeaways, yeah? And my 3 things that I've learned over the last, say, 3 or 4 years with containers and continuous delivery is one, that the container image becomes the single binary going down the pipeline. It shouldn't be the case that you package things and then, say, deploy it into a container right at the end of your pipeline. It shouldn't be the case that you do multiple packagings. I've seen that with some clients. Build a container, do some stuff, test it, build a container, do some stuff, put it into production. Really, the container image should be your single binary, the single thing that goes down the pipeline and gets deployed. Adding metadata is super, super interesting. Anyone who's bumped into the Equifax story, software supply chains, all these things, Equifax had some real issues with struts, happened to be a Java thing, but in terms of governance and provenance and monitoring what's where, I found, particularly in enterprise organizations, adding metadata is the first step to understanding what is where, if that makes sense. It's not so easy in container tech at the moment. We must also, and this is kind of agnostic to containers, but whatever fabric you're deploying onto, I did a talk at Java 1 a couple of years ago on cloud, and same kind of thing. Whatever you're deploying onto, whatever kind of fabric, we want to be abstracted away from it as developers. I'm sure most of us, I'm assuming at JAX, are kind of about coding things and so forth, but we've got to respect the underlying fabric. Running stuff on the cloud is different than a data center. Running stuff in containers is different than running it in cloud sometimes, yeah? And it sounds obvious, but I see many projects where people haven't made that connection yet. And in fairness, that's been me a couple of times. I'll show you one slide at the end where it's basically 3 things where my team and I made a bunch of mistakes when we were deploying Java into Docker in a production use case. And we've talked more about that. I can share some video links later. But we need to cultivate what Martin Thompson calls mechanical sympathy. Yeah? Developing just enough sympathy or just enough empathy for the target fabric so that we as developers get the best out of it. Yeah? This has been old school. People are doing like Java threading. You had to understand the thread model. You had to understand various different models before you could fully get the best out of it. Was that a question? Sorry.
No, sorry.
Oh, sorry. Cool. So yes, this is me. Love getting involved in the Twitters at Daniel Bryant UK. Work as a freelance consultant now. I was with Open Credo until March this year, and I'm working as a consulting CTO at a spin out of theirs as well called Specto Labs. Still doing hands-on stuff, do a lot of leadership stuff as well. Really getting into continuous delivery. That's what I'm enjoying, and that's where I seem to make the most impact in projects. So I've been doing this more and more over the last 3 or 4 years. Continuous delivery. Is everyone comfortable with continuous delivery as a topic? I think we're pretty well established now. I'm seeing nods. This is good. If you're not, that book is amazing. Jez and Dave, really solid book as an introduction, talking about producing valuable and robust software in short iterations, short cycles. And it's all about optimizing for feedback and learning. Feedback and learning, both from the technology point of view, but also from the business point of view. Getting stuff out in small chunks is less scary than doing big bangs, and we learn more from a business point of view as well. Not necessarily continuous deployment. Some enterprises I work with get a bit scared with the notion of continuously deploying things into production, and I totally get that. So continuous delivery kind of gives you the option to deploy, but you can still have a person signing it off if you want to. That's cool. Hopefully not a controversial statement. Creation of a build pipeline is mandatory for continuous delivery. Yeah, I think that's the book very much emphasizes that, and I've really dialed into this. And again, I use this presentation for multiple different language talks, but I'm primarily a Java developer. Most of my stuff is Java, to be honest. And this is a kind of standard CI/CD pipeline that I see in Java shops, and hopefully this will come as no surprise to people. I'm coding on the dev machine. I'm probably doing version control, at least I hope, in 2017. We're all doing version control. I sometimes see we're not, but you put it up to GitHub, say. Something pulls it down, maybe Jenkins, Circle CI, TeamCity, take your pick. You might do some code quality. I love SonarQube, and then ultimately, if it passes your code quality and all your other kind of checks here, find bugs, a whole bunch of stuff, you put it into an artifact repo, something like Nexus or JFrog's Artifactory, that kind of thing. Then you do some QA, you do some staging. QA may be more involving mocks and stubs, and staging maybe you're integrating with third parties and using their sandbox, something like that. Gets a bit more realistic. Ultimately, you deploy to prod, but continuous delivery doesn't stop there. I've heard someone, I can't remember who it exactly was, I know Adrian Cockcroft's mentioned this a few times. Continuous delivery and the life cycle of your service only stops when the service is no longer in production. Yeah? Monitoring, observability, all these things are a critical part of continuous delivery for getting that feedback loop. It's all very well having this super optimized, but if we can't observe what's going on, both from a technical point of view and a business point of view, how can we expect to optimize? Yeah? Kevlin said it in his keynote earlier on, automation, you can do the wrong thing very fast. That's DevOps sometimes, yeah? I see people automating stuff that's wrong because they haven't got this feedback loop. Feedback is critical. So observability at the end of continuous delivery, super, super important. The impact of containers on CD, well, containers pretty much, Docker have done an amazing job in terms of putting a nice API on it and marketed it really well. But containers, LXC in particular, has been around for many years, BSD jails, all that kind of stuff. Got a hat tip to Solaris as well, with the zones. It's fundamentally OS level virtualization. And this, for Java developers, makes a lot of sense typically. We have hardware virtualization, so VMware, Xen, the cloud pretty much. We have application level virtualization, the JVM, the Java Virtual Machine is an app level VM. And now we have something in the middle, OS level virtualization. It's aiming to be the Goldilocks level of virtualization. It's not too hot, not too cold kind of thing, yeah? In that it's not down to the metal, and it's also not up to the JVM, potentially. Although if you're running Java, you are involving a JVM. But that's the pitch of it. It's fundamentally C groups, it's control groups. Control groups control the resources your process can access. Namespace controls what it can see in terms of networks and other processes. And a rootfs is basically a pivot file system. You are not giving your container root access to your root file system, if that makes sense. You're typically mounting somewhere else and saying that's your root, and you can destroy it if you want, but it doesn't destroy my local machine or my server, for example. That's pretty much containers in a nutshell. The key thing is, as I mentioned before, now the container image is the single binary that goes down our pipeline. For me, when I started my journey with Java 17 years ago now, pretty much, the single image was often, the single binary was often a war or a jar. Yeah, particularly war. I did a lot of Oracle stuff, packaged stuff as a war, and then we put that into, Oracle Application Server, and that was kind of the thing delivered. Now, we're putting that jar, that war, whatever it is, into the container, and that is becoming our unit of deployment. That make sense? Sweet. So how does it change? This is the one I put up first. This is the new world. And I've put it, excuse me for a second, I've put it with Docker. So I've said the containers change your pipeline like this. And only because I use Docker the most. I've used Rocket a little bit, and Cryo looks super interesting as well. But whenever you see Docker, please excuse me, it's really containers, these things. You need to be developing on a laptop that has got containers or Docker installed, and you're probably doing some basic smoke testing with the container on your laptop. You don't necessarily have to build stuff every time in a container, but you'd be wanting to test stuff in a container before you push it into, say, your version control. Where you store things, now you might not just store a jar, a war, you're going to be storing an image, and they're a bit different than jars and wars. Clearly, the way you spin up stuff to test is going to be different with containers, and the fabric we're deploying onto is different. You're probably, and probably should as well, be using something like Kubernetes, Mesos, ECS, take your pick, but you want something that's doing the scheduling and the orchestration for you. It's just too complex to do by hand. I do have a few clients that use things like CoreOS, and they do just run Fleet or very basic images where they have like Systemd managing containers, but in the vast sort of other area, I think using something like a Kubernetes, a Mesos or whatever, it just gets rid of so many headaches. It brings in a few new headaches, I'm not going to lie with that. Kubernetes is not super simple, but fabrics, they take away a lot of the pain of running containers, particularly containers on Cloud Fabric or Fabric, that's going to be scaling quite large. So that's how the kind of pipelines alter. Not fundamentally different. All your principles you've learned before stay the same. Few tweaks for how containers impact. So let's step through each bit now. So first off, developing locally. I do a lot of Spring Boot stuff lately, and I just code using IntelliJ. I just code normally. I'm running maybe some, my unit tests or whatever in IntelliJ. I might drop to the command line to do Maven, whatever. Some of my friends who do Ruby and Golang, like Ruby developers sometimes mount a directory into a container and actually develop in a container effectively. So you're developing the code which is being saved into a mount point, which is then mounted in a container, and you're hot reloading in a container. And people in Go often build static binaries, chuck it in a container, run tests. Me as a Java developer, I'm happy just to develop sort of using what I've always done, and then put it in a container to run some kind of smoke tests before I push up to GitHub, typically. Try to make build and test, trying to do basic sort of happy path tests, like I mentioned there, because I've seen some people, and I'll come on to some of the nuances later, but some people basically only coding in the same way they have done, and then pushing it up, and then letting it getting packaged into a container image, sort of purely in the pipeline. And there's a whole bunch of things I think are not so good with that. You don't get sort of comfort with using containers. If you actually install Docker locally, you're playing around with it a bit, we as developers get we build that mechanical sympathy. We start understanding more about containers. So I would say, code however you want, but do involve containers on your local machine, particularly if you're leading teams, and I'm sure many of you, coming to JAX, you are leaders, even if it isn't in your job title. As a leader, I strongly recommend building this mechanical sympathy within your team, getting people installing Docker, playing around with it, developing that operational awareness is super critical. A slight aside, so many people developing with containers are developing microservice systems, I think, And I saw this great article, and I say great in sort of air quotes again, but Hacker News, talking about, unless you can run your entire system locally, you are not doing a microservices system. And I was like, this person has clearly never run an application at any scale. There's no way, the clients I work with, I can install physically all the stuff on my local machine. Sometimes it's mainframe. Most of the Java stuff, much as I love Java, the JVMs are quite heavy in terms of resources. I can't spin up 100 JVMs on my system. So I think this is a bit of a problem. I actually blogged about it when I was working at OpenCredo, like 2 years ago now. We were working with a company called Not on the High Street. Awesome company, check them out, and they're very generous with what they're sharing around their technology learnings as well. And we bumped into this. Working locally with microservices and containers, we used Mesos there to deploy onto, was genuinely quite problematic. And I blogged a few sort of ideas that I bumped into and shared a few things, and I've been super lucky now to work with a couple of companies to help create open source tech. So I'm not the one creating the tech, I'll be very honest with that, but chatting away with them. DataWire, if you haven't seen DataWire, they're a very interesting Boston-based company. One of the things they use, have developed an open source tool called telepresence. And if anyone's using Kubernetes, this allows you, one pattern I talked about in my blog was environment leasing. So you spin up a QA environment. We actually did this on demand in Amazon. We created the ability to QA person or developer could spin up an environment on EC2. It deployed Mesos using Ansible and Terraform and stuff. And then you could basically have access to that cluster as your own little world. So you could deploy different versions of software into it, you could poke and play with it, and then at the end of the day you tear it down. And that got over a major limitation they had when they were using bare metal, is they could only have 10 QA environments at any one time. Things like telepresence allow you to work locally and proxy your work to the remote cluster. So I can be developing a service locally, Java service, and I can fire up telepresence, and my local service I'm coding away and debugging on can talk to the pods in Kubernetes like I'm running in the cluster. Yeah, and I can bring a shell up, I can see all the environment variables I would typically get access to in a pod. It allows me to it bridges the gap between the remote cluster and your local workshop. Classic thing the other day, I had some namespace issues or some network issues in Kubernetes, and I was running Alpine, which I'll talk about in a minute. Alpine is a very lightweight operating system, and all the tools I'm used to using, like dig and NSLOOKUP, weren't in the Alpine binary. I was like, oh man, I'm going to have to pull the image down again, install all the Alpine tools, and then push it back up into the Kubernetes cluster. And I suddenly realized, no, hang on, I've got dig on my local machine, on my Mac. I can just telepresence into the cluster and dig. And that's what I did. I fired up telepresence, digged the route I was looking for, figured out the error, and fixed it. So things like this are very useful. Open source tool, check it out. I love it. Second one, shameless plug for Spectre Labs, company I work for at the moment, consulting. And I found myself using these kind of things, service virtualization or API simulation a whole lot. And basically, there's things like Hoverfly, it's an open source tool, Go-based open source tool. Anyone use Parasoft or HPE or CA do very similar tools. This one's more lightweight, but you can basically create virtual services. You can either record and replay traffic against, say, an external service, and then you can get rid of that external service. And Hoverfly captures the data that the external producer you're consuming. Hoverfly sits as a proxy. It captures the traffic. You can get rid of the external service. You can run this in your CI pipeline. And locally, when I'm developing, in particular, I'll often be, say, spinning up like 5 Hoverflies of fake services that would typically be really resource intensive locally, and I'm coding against it's just a very sort of simple proxy. You can do the same with Nginx, returning like a file, streaming a blank file. I did some similar stuff with Node and Express, things like that. But these are 2 patterns I found really useful. This kind of environment leasing, connecting as I'm developing locally, connecting into a remote cluster, and this service virtualization. There are many tools, Mountebank, WireMock, take your pick. These tools these patterns I should say, found really useful.
Is that just for HTTP or is it for any TCP/IP protocol?
Hoverfly, for example, does HTTP and HTTPS. Mountebank does TCP as well, I think. So ThoughtWorks have created a tool. It's a node-based tool called Mountebank. I'm pretty sure that does TCP as well. Also check out Envoy, so that's like another kind of proxy. That one is lower level, layer 3 stuff as well, so may answer your question there. So there's your link, so you can check this stuff out later. So a bit of a digression there, but if you're working with microservices, check those things out. I've frequently been asked this at the end of the talk, so I chucked it in. Key thing is, whatever you're deploying on, use the same base images locally. I see some developers working with Ubuntu locally because they're comfortable with Ubuntu, but then they're deploying into CentOS in production. and there is subtle and not so subtle differences between Linux distros. So a whole bunch of security issues and other things I've bumped into over the years. So the kind of key takeaway, actually I've jumped a slide, kind of key takeaway is make an effort to understand what you are running in production, what your InfoSec team, what your ops team is happy running in production. There's another slide, but hopefully it'll nail that point home as well. I've learned in my sort of foray with Docker that the Dockerfile contents are super important. And it's basically, this is a classic, very simple Spring Boot app I think I was running at the time. With Dockerfile, people aren't familiar, it's just a manifest effectively for how you build your image. I'm taking OpenJDK. Base image there, so I'm building upon, I think it's Debian maybe in there, Debian Jesse. I'm adding in my binary. I've got like a shopfront binary I've built using Spring Boot. It's like an uberjar type thing. I'm exposing a port that's going to be running on, and here I'll talk about more this stuff later. It overcomes an issue I often see, but I'm effectively doing Java, jar, running my app. Pretty simple, but there's a whole bunch of questions that many developers I work with are not comfortable with operational stuff. This is the first time they've been exposed to this stuff, yeah? I've been done workshops recently where I've said, fire up Vim, do this, and hands go up like, what's Vim? What's a terminal? And it sounds a bit funny, but as in, you've got to respect that some people just want to write code, and I totally respect that. But I've made this mistake. We have to work on educating people. Do you want to be, in the Java space, do you want to be running a JDK or a JRE in your image? JDK is great for developing, JRE, smaller surface, for production, which makes a lot more sense. But a lot of developers haven't been exposed to this stuff. I won't cover the other languages quite so much, that's the thing. The key takeaway I've kind of hinted at already is talk to the operations team, talk to the sysadmin team. Their operational knowledge is genuinely, genuinely invaluable. I know this is the kind of cliche of like talking to InfoSec or ops and they're not very friendly. The vast majority of companies I go into, there may be a bit of friction for historical reasons, but when you engage them really early on in the project, they're actually really happy. Yeah, they like you. We say, hey, we're going to be running containers, and they're like, whoa, that's pretty scary. And we work through, discuss the problems with them, address their concerns, and they give us a bunch of knowledge in return. So this is really key. Doing a container project, doing continuous delivery, get your ops people involved as early as you can. Get your InfoSec people involved as early as you can. I bump into quite a lot people running different test and prod containers. So they have like a full OS, I mentioned already, Ubuntu for example, and they've got all these test tools there, and they deploy something different in production. They have like a lighter weight container in production. But it's very easy to see configuration or application drift in those two containers. Yeah, very easy. I like using the pattern of test sidecars, and there's an interesting proposal by Alexei, but test sidecars basically mean you only build your container image once, but if you want to run tests against it, you build another container, which you then link with that container when you're running in, say, QA, and that contains all your tools, all your data, and that kind of can be used to drive the tests. So you always keep your production container clean, and as it will be in production, but then you have this sidecar container you can bolt on with extra stuff. And Alexei actually talked about having this notion of on test as a kind of command in the Docker, in the actual Docker file. It never happened. It's been a couple of years now, but it was an interesting read. I think I've got the link there. You can check it out. I found a lot of value in reading that. And funny, I think it was March this year at DockerCon. I wasn't there, but I heard about this. To some degree, you can get around this stuff now by using multi-stage builds in Docker in particular. So this is a Docker-specific thing. If anyone's used to Docker, you'll recognize this is a bit funny. You've got two froms in one Docker file, but basically you're building from, in this case, it's Golang as builder, and then we're repackaging in a lightweight Alpine-based container, and we're saying like copy from builder, so copy the artifacts from the builder and put it into a container. You can do the same thing with Java. You could be doing from JDK, and then you can be like doing from JRE down here. You keep it all in one file, and that for me is good enough to minimize the drift you see in configuration, I think. But standard caveats apply. I see some people putting loads of tests in this bit as well, and then producing a very lightweight container at the end. But it's an interesting pattern. Java-specific stuff. People last time I did this talk asked me, is there an Oracle JDK Docker image? The answer is yes. Oracle leveling up their game. I think Microsoft are kind of kicking on a little bit with the open source stuff. So Oracle have got a nice GitHub repo. You can get Oracle images using Oracle Linux, which is based off Red Hat Linux. And you can get it for, you can't get it for Java 9 yet, funny enough, but you can get it for Java 7 and Java 8. So you don't need to run the OpenJDK. I like the OpenJDK. I run the OpenJDK in production, to be honest. But some of my clients insist on running Oracle, and you can get an Oracle Docker image, Oracle Java Docker image. Hot off the press, JDK 9 has basically created a, the terminology right, but a port for Alpine. So it used to be really tricky. Alpine is a really nice, lightweight operating system, very container friendly, but it's very minimal, and it also doesn't use technical details. It doesn't use glibc, it uses muscle to do some of the syscalls and so forth, which meant that OpenJDK had issues if you were trying to deploy it into Alpine. OpenJDK JDK 9 has actually got a port where you can now download the JDK straight away and plug it into an Alpine container, which is super awesome. So it is officially early access, so I don't think like it's sort of guaranteed for production, and I haven't used it in production yet, but I think it's an interesting way. I often try to modify Alpine builds to get the OpenJDK to work, and you can certainly do that. I've put some stuff in my GitHub on how to do that, but this is even better. JDK 9, new ways to run Java in a lightweight container. Hot off the press, we're going to be talking more about this tomorrow, but modularity, Jigsaw, very interesting. Yeah, this book is an amazing book. Like it's the Bible basically for Java 9 module stuff. If people are familiar with running lightweight Docker images, so using things like Debian Jessie or Alpine as the core base, you might have also been exposed to things like unikernels. Now unikernels, they were reported as the next thing for containers for a while, but fundamentally unikernels just allow you to modularize your operating system. So if you're not using some parts of the OS, you could in theory not include it into some form of image. So unikernels, basically you can specify what you want in the actual OS, and you build it and you run a unikernel typically on a hypervisor. Yeah. So I haven't used them much. I haven't used them in production at all, to be honest. It's an interesting thing I keep an eye on. But one thing that Java 9 brings in now is the ability to create minimal runtime images. So no longer do I have to run a full JRE, I can use various tools, and JLink in particular, to create a minimal runnable unit of Java effectively, which is pretty cool. Not play with it much, in all honesty. I'm putting it out there as more of a, hey, check this out if you're interested. I'm certainly going to be playing around with this because there is a few use cases I see, but you can effectively create a slimmed down version of the JVM for running within your containers, which I think is very interesting. And this book, amazing stuff. Benefits, obviously, reduced footprint, performance, and the security attack surface is all minimized by doing this stuff. Moving swiftly on, taking a breath for a second. So I apologize, I do talk fast sometimes, so get a bit excited with the tech. So moving on to more of the actual building of the things now, building of containers. I'm not going to go into this in vast amounts of details because the report goes into it. It's a bit dry in terms of, I use Jenkins a lot. There's an awesome CloudBees open source plugin to manage, after you've done your Maven build, a clean install, or after you've done your Gradle build, it's all nicely configurable. You can then package that thing, that artifact, that jar, that runnable jar, say, in a container. And then you push the image to a registry. So used to pushing, say, jars and wars to Nexus or Artifactory, the same kind of deal with images. You now push the image. You can push the jar and the war as well, but you must push the image because that's what's going to be deployed. I use Docker Hub quite a lot. I've run some private, or my team, I should say, have run private registries as well in the past. Take your pick. Yeah, there's a whole bunch of, a whole bunch of new things out there. Closely related to storing of the image, a few things around metadata. First off, beware of using the latest Docker tag. So you tag your images when you build them, but the semantics of the latest Docker tag are not what you expect. Totally been burned by this, yeah. Particularly if you're on a team doing CI and CD, and half the team is doing labeling and so forth, and the other half is not. Or sorry, half the team is doing tagging of images and half the team is not. What we're running sometimes locally and in production, didn't get to production luckily, but what we were running in local and QA was not actually the same image, even though it was the latest image. So this article, you can have a Google for that one, covers the details. Just wanted to put it out there as a warning. Use something like Semver, semantic versioning, big fan of that, every time you build and push. And same thing in your CI as well, in your CD. I've learned the lesson, particularly in enterprises, having things like metadata associated with my build artifact is really good for provenance in terms of governance and software supply chain. When did I build the thing? What's the git char of what I've put in that container? Build date, image name, vendor, all these kind of things. And in particular, when you start doing QA on an image as it's going down the pipeline, you might want to put things like QA controls. You might want to sign the binaries saying, yes, we as QA have looked at this binary, it is good to go, that kind of thing. You might want to put security profiles associated as metadata. So for example, you must always run this container with AppArmor running, or SecOmp, that kind of stuff, if you're hardcore into your security, which is really good, to be honest. And you might want to say whether the image itself has been audited. Now, Gareth Rushgrove, the gent behind DevOps Weekly, anyone subscribe to DevOps Weekly newsletter? And if you don't, it's totally worth doing. Even if you're not super into your ops, DevOps Weekly, I've learned a bunch from Gareth over the years. He's talked around the importance of manifests and software supply chains and all these things. And again, time and time, we're bumping into issues now where people have either lost track of what's in production or they're playing ignorant, in terms of when problems crop up. So Docker has got labels. You can fundamentally, web page pretty simple in terms of how you actually add labels. It's a way of adding key value data to images. So here, I did it on a script. So you've got like a label here. You can namespace it like you're used to with your Java packages. We can namespace there. This is a microscaling systems example, and you can add lots of data to the image if you like. There's a make file, because sometimes it's quite tricky to add all the data you want. So I'm a big fan of make, to be honest, as much as I love Maven and Gradle. Make is really nice. There's a make file from Microscaling Systems, which they've open sourced, and you can use it to automate a lot of the labeling, such as the git char, the build date, the owner of the image, that kind of thing. So you can run the make file locally, or you can run it part of your CI/CD, and it bakes in the current data into your image via labels within your Dockerfile. Yeah. There's a couple of references there. Label schema, proposal for making the labels more structured. Docker are pretty casual with that at the moment. Docker are pretty much saying, do what you want with the labels. A few people have got together and said, we think this is the right way of doing it, so check that out. You can't really add labels at the runtime yet. Yeah. So say you're pushing stuff down your pipeline and you're doing QA sort of tests, you might almost want to say, well, this is past QA, add a label to it. You can run, say we're running a Docker container here in daemon mode, and you can add a label, but as soon as that container stops running, the label disappears. It does not get added to the Docker file, for example. It does not get added to the image. You can Docker commit the image that you've run, but it creates a new image. So that violates my kind of single binary thing. Yeah. It's not possible at the moment to basically update running containers. So you've built your container image, you've put your metadata into it, you can't add it dynamically as you go down through, like, say, QA and stuff. There is a GitHub discussion, which I've got involved in as well, about, can we get this, please, Docker? And there's been kind of not that much interest, and I kind of get it now. And there's a few people coming up with ideas, alternative ways to do this stuff. So Liz Rice, hat tip to Liz Rice and the Aqua team. Aqua do awesome stuff around security of containers. They've come up with this, it's called Manifesto, and it's a way to store basically metadata within a Docker registry. Yeah, so like Docker registry, not only can you store images, but you can actually store data blobs. So it's a proof of concept. Liz is very clear of that. They're working on productionizing it. Proof of concept. It's a nice way. If you're already running a Docker registry, you can now store your metadata very close to your images. So I'm really keen to see how Liz gets on with this stuff. So hat tip to Liz there on this. What I often do at the moment, to be honest, is I don't try and store the metadata with the image. I use Nexus a lot, and Nexus now you can deploy or store your jars as well as your images in your Docker images, your container images. And I'll add metadata as you do with Nexus. Same with JFrog Artifactory. You just basically add metadata into the registry. And as this is a conference with a code of conduct, I will point out the frog is purely hugging the whale there. That is straight from the marketing, like the JFrog market. And I looked at it and thought, that's a bit weird. But yeah, as in, it's basically they're saying they love Docker and that they have abilities to not only push jars and wars, but you can push now the Docker images up with it as well. So this is a nice alternative. Moving down through, so the QA bit, I'll move through this bit quite fast because some of this is quite context specific. But often I find myself wanting to do some form of component testing. So in my book, trivialized example, a couple of Spring Boot apps, a Drop Wizard app, basically a shop front. My UX skills are super poor, so it's really basic UX. But it's like a microservice type system where the shop front talks to the product catalog and the stock manager. I've used it as a way to demonstrate different types of testing with when you're using containers. Often in real world, you can have some kind of API gateway like Nginx up front, and you probably can have databases, so we can talk about that offline. This is a trivialized sort of simple example. I'm a big fan of using Jenkins, and particularly Jenkins Pipeline as code, because I can codify a lot of the stuff I'm going to show you in a Jenkins file. So in my repo, I've got all my Java code, I've got a Dockerfile, and I've got a Jenkins file that codifies a lot of this stuff, which I really like. If you haven't seen this is Jenkins 2, pipeline sort of as code. You can build arbitrarily complex pipelines, build various stages of tests and deploy these kind of things. Jenkins has come a long way. I'm a big fan of Jenkins. I've used it since the Hudson days. I use Circle CI quite a lot. Clients are really into Circle CI as well. But Jenkins, for me, gets me most of the way through the projects I'm working on. Testing individual containers with Jenkins, pipeline as code, combined with the CloudBees plugin for Docker. You can literally do simple things like this. You can run a Docker image, and you'll notice I'm not using a label, a tag, shame on me, I really should be using a tag there. And you just run it, and this is me just putting a very simple timeout, but in reality you can use health checks and various other things. And I'm just doing this one, excuse the bad syntax, but it's the way it kind of works in the Groovy script here. I'm just waiting, I'm saying 30-second timeout, wait until this script returns true, and all I'm doing is curling and grepping for up on the health check endpoint. But it's kind of, this isn't probably the best way to do it, but it's kind of an idea of how you can test, using things like the CloudBees plugin. Many people I'm working with now are looking at things like Concourse and Spinnaker, which offer, combined with health checks, you can kind of make your pipeline a lot less kludgy than this. You can wait until the container health check actually returns true before diving in and starting testing it. But it's one way of doing things. If you were looking to spin up a bit more, maybe doing a kind of security test or a load test or something like that, I often use things like Docker Compose or Kubernetes, same kind of thing. You create basically a manifest, a deployment YAML or Docker Compose YAML for the area of interest. So it might not be your whole code base, but you specify we need these things running together to be able to test them at a kind of end-to-end level. You can also, I talked earlier about running the sidecar service, so you can put a container here which depends on all these other services, which contains all your tests as well. So you can basically spin up your system under test, deploy a sidecar container all configured here as well, which then starts hitting the endpoints. Do security testing or load testing, functional testing. This is sort of one pattern I use quite a bit. Example here of me doing similar kind of stuff with the Jenkins CloudBees plugin and the pipeline as code. I'm basically doing, I'm using Docker Compose running in daemon mode. I've spun up a node on Amazon, for example, and I'm running Docker on that node. I deploy all my services into that node, so it's like a namespace effectively, and then I'm running tests. And here I'm just curling like the actual website and grepping for the HTML coming back. But you get the point, you hopefully get the point in terms of you can spin stuff up, you can run some tests. This is one way of doing the kind of component end-to-end tests by using things like Docker Compose, using things like Kubernetes deployment YAMLs as well. I will mention, again, another DataWire thing, which I saw the other day, which is kind of cool. They've got this ephemeral Kubernetes cluster. So you spin up a bunch of clusters in the background on Google Cloud or Amazon or whatever, and then Kubernetes manages these pool of clusters. So when you're doing CI/CD, you can effectively claim a Kubernetes, and then you can deploy your stuff into it, run your tests, and then give it back, and it will scrub the cluster for you, make the cluster clean. So it's a nice way of kind of like thread pooling, that kind of thing. It's a nice way of managing say 4 Kubernetes clusters that you're using in production, for testing, I should say. All open source again, it's super interesting stuff. I would say testing what we call like non-functional requirements or system quality attributes is super, super important. I'm a big fan of using things like Gatling at the moment. Gatling is a Scala-based DSL. You don't have to know any Scala, to be honest. I don't know any Scala really. But it's a really nice DSL for describing how you're going to, like, how your users will use the system, how many users you want attacking the system, kind of thing. If anyone's used JMeter, for me this is kind of the modern version of JMeter. JMeter is a bit clunky in terms of its UI and stuff, and the XML, whereas Gatling's all DSL. The cool thing with Gatling is once I've done my, or once the team and I, we've done our kind of very simple performance testing, load testing, which we run locally and in the pipeline, we can take the exact files, the exact DSL files, upload them to flood.io, and Flood basically, it's a commercial service, you have to pay for it, but they will run your Gatling scripts on EC2. So you can then have that a fleet of things, like repeatedly doing what you've already coded locally, but against your staging environment. So Gatling for me is almost becoming sort of the lingua franca of like ways to do performance testing. And there's a couple of commercial services. There's even a free tier on Flood, which you can use to make the thing, make the things you're running against your system, you can make it that much bigger, that much more realistic. Even without the kind of Equifax stuff, hopefully security these days is kind of table stakes for people in the room. Some of my clients, it's not, and I get it. It's hard, it's expensive, sometimes, but it is table stakes. You have to have security baked into your pipeline if you want to be trusted by customers, basically. Yeah. So things like find sec bugs is a security version of find bugs. Totally worth checking in your Maven or in your Gradle. OWASP dependency check is kind of like a Maven enforcer, if anyone's seen that. It maintains a list, like OWASP are an open source consortium that talk about web security. And the dependency check basically looks in the dependencies you're bringing in and checks against a list of known critical vulnerabilities, CVEs. So if you're bringing in, say, like an old version of Log4j, it will complain at you and say, hey, this Log4j has got like a critical vulnerability, and you can fail the build, that kind of thing. If you're looking at sort of doing automated penetration testing, I'd totally check out BDD Security with OWASP Zap. That's a way to create a given when then style test, which does some very simple things like SQL injection, cookie hijacking, all that kind of stuff, which you can do in your pipeline, which is quite nice. If you're building containers, you must not only scan your code, check your code, because we're obviously responsible for that, but you must be responsible for what's coming into the image as well. So OpenSSL, classic example. Things like Docker Bench for security and CoreOS Claire are tools to statically scan images for known library vulnerabilities. They don't really look at your code, they look at the OS and the tools you're bringing into that Docker image, that Docker container. Docker Bench you have to pay for. CoreOS Claire is an open source project from CoreOS, but running it is a bit of a pain. So I bumped into a gent at a conference a couple of weeks ago, and he's put together a really cool Dockerfile that actually makes running CoreOS Claire in your pipeline much easier. So I've put some links to that in the back of the presentation. So hat tip, I've forgotten the gent's name, but hat tip to him. I looked at it and it looks really cool, because I was saying to him, I'm really struggling running these scanners for projects where we don't want to pay for, for static scanning, and that is one solution. Although I highly recommend if you're using Docker Hub or you're using Quay, CoreOS's version of it, you can pay a little bit extra and get the scanning, and I totally would recommend doing that in general anyway. Lastly, another link for you down there. I read a lot of books. I just a long commute and stuff, so I love reading stuff. But there's a great article. If you're new to the world of containers and security, there's a gent called Aaron Gratifiore. He writes for CIS and runs a security company. And I basically saw him talk at DockerCon, and he just gave a gold mine of information for every different level of kind of interest and knowledge that we as developers should care about the container. So different security things within the container. So it talks about namespacing and seccomp and all this kind of stuff. I learned a bunch from that. So key takeaway is do think about quality attributes, non-functional requirements, and do test them in the pipeline. One thing I would say is I do get pushback from some clients, particularly people that are investing heavily in Agile, and they say we're not going to do things like non-functional requirements to the last responsible moment. Yeah, and this last responsible moment is a nice idea, particularly when you're building systems that you don't know properties of, because you basically defer the decisions from where you don't know very much to where you do know stuff. So you don't do stuff up front, you make the decision further down the line, yeah? And so basically that's the point. If you didn't make the decision then, it would be irresponsible. So that's the last responsible moment. But when it comes to things like security and scalability, for me, the newsflash, sometimes the last responsible moment is actually up front. Yeah? We need to understand what kind of security implications our application is going to be exposed to. What kind of scalability will we need to actually build for? Otherwise, it leads to this. A lot of this I've seen. You know, I can fix it this right, or I can fix it fast. Show me what fast looks like. And you know, you can just see these things over time building up, where people have bolted on security enhancements, bolted on scalability enhancements, these kind of things. And yeah, I say think about these things if you can up front. Get InfoSec involved. Get the ops team involved. Containers and microservices, in my experience, haven't made this easier. I had one project where we tried to retrofit security stuff onto microservices, and it was just a nightmare because they'd all been built in different languages and different styles. We couldn't retrofit security onto it. It was really, really hard. So same thing with containers. You need to think about all the things you're using in your project and then discuss them to a comfortable degree up front. Is everyone comfortable running containers? What is the security implications? That kind of thing. This is a slide I hinted at earlier. So mechanical sympathy and Docker, a couple of things to be aware of. And JDK 9 has addressed the top issue, but JDK 8 and 7 are still affected by it, and it's not going to be backported as far as I know. But the JVM, it was hinted by a gent from IBM actually. The JVM, you know, it's 20 years old, yeah? It is not control group aware. So the way it understands what hardware it has access to is not Docker friendly, not container friendly. So classic example, once I was deploying, or my team and I were deploying, say like 30 containers, 30 small containers on this Amazon box, you know, massive amounts of memory, but it had 32 cores. And the idea was we were going to pin each Docker container to one core and give it like 4 or 8 gigs of RAM or whatever, what the number was. The problem was when the JVM spun up, it looked and it thought it had 32 cores. We've pinned it to 1 using a control group, because the control groups, you can say, only give this process access to 1 CPU, and the control group enforces that at the OS level, so there's no way the JVM could get more than we'd given it, but it thought it had access to more. Yeah, and so it reported incorrectly the number of CPUs, and unfortunately, the number of CPUs affects the things like the fork join pool. And it affects things like GC and all these things. So a couple of applications basically ran like a dog because it thought it had access to all this material, but the Linux file system was saying, no, you don't. You know, so watch these things. Same with memory. Bear in mind you need a bit of overhead. Don't set your container memory limits to just the heap size. I've done that in the past. But you need to allow room for permgen or metaspace on top, and a bit of extra room, particularly if you're building an application with a whole bunch of threads, because threads use native memory outside of the JVM. So give a fair bit of headroom. You know, your mileage may vary on these things. Lastly, think about entropy. So entropy is used to generate randomness for crypto and security operations. So I've seen a bunch of things where people have deployed applications into a container, and then the application is just froze. And we started debugging it, and we figured it always froze on a security operation, generating a token, doing crypto, whatever. And then we actually figured that we were running lots of containers on this single host, and we had exhausted the randomness. We'd exhausted the entropy on this box. And the entropy, so the way you get it, the way Java gets its entropy from the file system is it looks at dev random. Anyone's familiar with Linux? And dev random is blocking when there is no entropy. So if the box has got no randomness, it looks at it, it blocks. You can use urandom instead. That's something to look at. Some people say there may be security implications with using these things. But if you remember from the container metadata I showed you earlier on, the image file, next to my java-jar, I had like a funny looking string which basically said use urandom instead of using dev random. Right, I'm conscious of time here now, so I might whiz through. Deployment, I'm actually going to skip that one. It's not, these things are more, I've added on as kind of bonus slides, but observability is super important. Once you've deployed things, a couple of references there for you to check out that I found useful over the years. What I would say, you know, containers are clearly not a silver bullet, yeah. Very useful tech, but not a silver bullet. Do you want to go all in? This is the vision. A lot of vendors might want to sell you. You know, anyone from the ESB days will probably recognize all this kind of like posh marketing literature. But I often say start simple, yeah? You know, prove it out, get comfortable with the tech. I know this image is often used as derogatory towards Docker, but as in, I think it's a great image, yeah? As in, start simple, get comfortable as a developer, get comfortable as an operations team, and then scale out, yeah? People often say to me, oh, this Kubernetes stuff looks super complicated, should I build my own container platform? I say probably not, yeah? Unless you're Google, Amazon, or IBM. Then it's fine to build your own stuff. You often do find yourself building glue components of the system you're deploying onto, be it Kubernetes, be it ECS or whatever. Whatever you do build in terms of infrastructure, either you or your ops team really must treat that in the same respect as we treat application code. So build a pipeline to test the infrastructure and the application code together at some point. Awesome book by Keith. It won't make you like a Terraform or Ansible expert, but it will give you all the key premises of using infrastructure as code, using CloudFormation, using Puppet, using Chef, those kind of things. Fantastic read, really good. Final thing to walk away from, containers change the deployment mechanism and so forth, but they do not obviate the need, do not get rid of the need for good architectural practices. Yeah. So I see this a little bit. This is Casey West did this slide, and basically I've copied the slide because it says it all perfectly. It's not my work. This is Casey's. Yeah, that I've seen people chuck an API on top, chuck an application into a container. Please don't. Think about the bigger picture kind of thing. In summary, I won't read through because we're pretty close to time, but the takeaways really are continuous delivery is super important. Things change with containers, but the principles are fundamentally the same. Think about the images now as a single source of truth. Definitely add your metadata. And we as developers need to make, it's the whole DevOps thing, really. We as developers need to invest in understanding the fabrics we're deploying onto. And be aware that not everyone in your team will want to. So if you're in a leadership position, you've got to take that on, I think. The tooling is becoming stable and mature. When I started working on this stuff, my team did a fantastic job 3 or so years ago. Hat tip to the Open Credo team there and not on the high street we were working with. And we were cludging stuff together because it was all super experimental. Now the technology is there, you just have to weave it into your continuous delivery pipelines, weave it into your kind of common practices. Yet more books for you, yeah, because I know you love reading. These books that I found really helpful are my journey of learning about containers and continuous delivery. It's a journey that will never end. I try to learn as much as I can all the time. On that note, apologies for the rushing slightly there, but thanks for your time. Really appreciate it.